Losses? What does it mean exactly?
Well, the various types of time, energy, efficiency and financial loss in the factory include what we call the 6 major losses. I'll run through them. When machines suddenly break down, you get what we call breakdown losses. And if you have downtime because of lengthy preparation for some setup procedure, you get setup losses. Then there are problems when machines are left idling because the workflow is not efficient, or when faulty products are detected by the sensor and you have short stoppages. Those make up type number 3. Next, if there is trouble when you operate machinery at the design speed, which means you have to run at a reduced speed, you get speed reduction losses. When you get defective products which have to be thrown out or reprocessed, you have defect losses. Finally, you get yield losses if there are difficulties starting up again after resetting, and defective products are the result of constant stopping and starting. Those 6 losses are a real problem.
Let's get rid of them right away then.
That's the spirit, my boy. Splendid, splendid. But how are we going to do it? That's the next problem we have to face.
Oh, 6 major losses. But it's natural. Machines have problems. They're not losses.
Yes, they are. I don't think it's natural at all.
Whatever you say, machines are machines. They break down.
That's right. We don't waste time doing the setups, do we? That's just the way machines are made. It can't be helped.
Yeah, there's another point. Recently, we often have to set up for one product, produce a few things, and then have to set up again. Can't we do anything about that, huh?
But customers demand a big range of products in small quantities, so that's the way we have to do it.
It's true that resetting takes time. That's why we have to work so much overtime and come in on holidays. But, you know, maybe there's just no way out of it.
So, if possible, let's do everything a bit quicker then. Eh?
We're doing as much as we can already.
Hey, I'm not talking about you.
Okay. But anyway, about work stoppages. I never had any trouble with them.
Yes, that's right. You sure haven't.
You better believe it. I've been doing this for over 40 years.
Yeah, but just short work stoppages aren't really major losses anyway, are they?
And speed reduction losses. I mean, machines can't help that. Same with people. They slow down when they get older.
Not me. I'm not slowing down. Not in anything.
There are all these different types of loss, but what can we do?
Just a minute. Listening to you lot, it sounds as though we can't improve anything. Who was making lots of noise just now about getting rid of losses right away,
eh? Well, gentlemen, I'm glad to see you're thinking. But just thinking doesn't get rid of losses. But if you really try to think about the reasons for problems, you can often come up with a totally unexpected solution, you know?
I can't believe that. When you find the reason, I think it's more likely you'll give up, because there's nothing you can do.
Giving up, then, is totally wrong. Once you've found the cause of the problem, you have to carry on and ask yourself, what would happen if we made this adjustment?
It's easy enough to say that.
My dear boy, you've got a brain. You should put it to use. Without giving the point enough consideration, you're giving up. As for breakdowns, if it's a recurring type of breakdown, you just give up and don't bother to do anything, right? And you tend to blame speed reductions on the aging machine, right? And with resetting losses, it's like refusing food you haven't even tried.
Well, yes, it is a bit like that.
But why are bad products produced? Why do breakdowns occur? Why are there short stoppages? By repeating why, and examining more and more, you should be able to find a solution. If you all think together, you'll probably come up with a great idea. And I seem to remember one of you wasn't taking short stoppages very seriously. But you mustn't ignore them, you know. It's in fact one of the most important types of loss. If you add up all the time lost from short stoppages in this factory, you'll be amazed at the total, I guarantee. In one factory I know well, it amounts to tens of thousands of hours every month. Anyway, let's try and get rid of the big six as soon as possible and create a more productive workplace. They're 6 tough nuts to crack, but don't give up so easily. All right, gentlemen? I'm sure you can do it. In fact, I know you can do it. Splendid!
Let's take a look at some ideas that were put into practice in several plants that have won PM awards for their success in getting rid of the 6 major losses. In this factory, a 15-minute meeting is held every morning. The participants are leaders of the maintenance and production sections. The purpose of these meetings is to work out a countermeasure strategy for dealing with short stoppages. Individuals are encouraged to raise problems from their own section for instant discussion. Solutions can then be swiftly implemented. As a result of these meetings, the number of problems has been reduced from well over 1,000 per month to around a dozen. In this production area, they have implemented improvements at about 600 different places. This is a classic example of a full range of improvements which succeeded in removing all 6 of the major loss types. For example, the metal waste from one machine used to be about 20 centimeters long, and it was a prime cause of breakdowns and defective products. By implementing a number of improvements, the waste was reduced to just a few millimeters in length, and both breakdowns and defective products have been reduced to almost zero. Now let's look at some more specific examples. The first example is this cutting machine. Fine filings used to fall through the channel holding the cutting blade and also fall off the edge of the cutting table onto the rubber wheel below. The filings caused damage, and as a result, the machine regularly broke down. For a long time, everyone thought it was impossible to prevent filings from damaging the machine. But at last they couldn't stand it any longer, and the operators decided they had to improve the design somehow. They managed to design an original improvement by adding this effective wheel cover and waste channel, which keeps the waste away from the workings and concentrates it in one place. Cleaning time has been greatly reduced, and breakdowns have been reduced to almost zero. The workers in this next case used to have the attitude that all they had to do was to cover up all problem points. But as they learned more about TPM methods, they decided to check whether the covers were really necessary and efficient or not. In other words, their way of thinking was completely reversed. It was a major step to remove all the covers and reconsider what to do with all the equipment. Transparent acrylic covers were installed so that they could actually see what was going on inside and root out problems immediately, but only where they were thought necessary for safety reasons. Before the improvements, downtime in this section amounted to more than 1,000 minutes per month, but that has now been reduced by well over 90%. perfect setups the first time. What do they mean by that? Well, let's take a look at the before and after figures for this next machine. Before improvement, setup time here was 6 minutes, and the adjustment period was also 6 minutes, and at least 5 test products had to be made before full operation could begin. But after the implementation of one-touch die replacement, the setup time was reduced to 2.8 minutes, and neither adjustment period nor test products were necessary. In other words, this was a very successful, epoch-making improvement. In this factory, sections which were thought to be doing a particularly good job were designated as model lines. All the plants which have been awarded PM prizes, in fact, considered all the 6 major losses very seriously. This, of course, involved spending a lot of time to come up with ideas and experimenting on a trial and error basis, all in the attempt to remove the problems associated with the 6 major losses completely. The striking results here include 0 breakdowns, 0 defective products, and 0 short stoppages, as well as a resetting time reduced from several hours to just 10 minutes or so.
Well, what do you think? The examples we've been looking at are real proof that the 6 major losses can be eliminated with the right attitude, sufficient effort, and determination. The results can be very impressive indeed and make your workplace a much nicer place to work in. You just have to change your way of thinking a bit and work at it. Right. Next question.
Professor, I'm not a maintenance person, so why do I have to learn all about the equipment?
Well, my boy, think about your health for a moment. Do you leave everything up to the doctor? No, of course not. If you drink too much, you know what to do, right? If you think you're catching a cold, you decide to have a nice hot bath, take some medicine and go to bed early, right? In other words, you use your own judgment about the maintenance of your body. You understand your body condition better than anybody else. When it comes to your work, you should know about the machines you work with better than anybody else too, and try to keep them in a good working condition all the time. That's your job, right? It's a matter of communication between you and your machine.
Yeah, but machines don't talk, do they?
That's the point. That's why you should understand your equipment better. By the way, how are your machines today?
Well, let's face it, our job is just to produce things, right?
Yeah, but we don't know much about the machines.
But that's okay, isn't it? That's what maintenance staff are for.
The T in TPM means total, and total includes everybody. TPM is like equipment health control. Everyone's responsible for the health of their own machine, just like you worry about your own health. Maintenance staff are more like doctors, you see. They can't look after everything, can they? But if we say the machine is their job, I'm only an operator, we'll never get anywhere.
But those guys tell us, don't mess around with the equipment. You'll only make matters worse.
That's why you need to know more, so they know you know what you're doing. We should try to do maintenance ourselves.
And make life easier for them.
No, they have specialized stuff to do. It's not an easy job. Anyway, the more we know, the quicker we can see problems coming.
Oh, all this stuff about studying the machines. It's a lot of hot air. What it takes is experience and sense. But you young guys will never understand.
You can't rely on just experience and sense.
You don't think they mean anything, huh?
No, of course I don't mean that.
Look, for 40 years, they've called me king of the lathe. You trying to put me down or something?
Don't take it personally.
Well, I guess I haven't got any sense at all.
I know what you mean. I'm the same. But if you haven't got experience or sense...
What that means is you ain't a pro yet. That's what it means.
What do you mean by that?
Cool it, guys, cool it, cool it.
Yes, gentlemen, do cool down. The point is that it's too late once you get a breakdown or produce defective products. When we suspect they might happen, that's the time we need to find abnormalities.
You mean that's possible if we fully understand the equipment? We just have to find abnormalities?
No, no, no. As early as possible, you need to do something about abnormalities to get the machine back to normal.
What happens if we can't fix it ourselves?
Well, that's when you have to report to your boss or call in the maintenance people.
Hey, boss, there's something wrong here.
That's not how to do it. Vague reports are no good. You have to report the abnormality clearly. At least, you must learn how to report properly.
Yeah, but after many years in the job, sometimes you just know when things are wrong.
Well, yes, that's true. But the trouble is, everyone senses things differently. So we have to establish specific standards for every part of the equipment and then try to detect abnormalities based on those standards. You see?
But who's going to decide the standards?
All of you are, of course. You all need that ability. Of course, you can leave regular inspection up to the maintenance team. But you've got to get into the habit of doing daily checks yourselves as well. The standards will make checking easier, I can assure you. The efficient operator will understand the structure and functions of the equipment fully, be able to find abnormalities quickly, do something about them, and keep the machines in proper working order all the time. That's really what it's all about, you know. But enough of my advice. You need to get on with it. Let's look at some real examples of what I've been talking about.
Let's take a look at education and training techniques at some ore plants which have received PM awards. At all of these plants, enthusiastic training of operators is a noticeable feature. For example, this plant emphasizes the 5 pledges of autonomous maintenance. They have excellent results here, finding equipment abnormalities, stressing the fact that operators should be able to do minor repairs themselves. In other words, autonomous maintenance. Of course, each factory has its own educational methods. But the training tends to be very similar with regard to certain basic techniques which must be stressed in the early stages, such as the tightening of bolts. This particular training session is demonstrating the relationship between the amount of grease and temperature. The situation here used to be like this. If anything was broken, you would ask the maintenance staff to fix it. Ordinary operators simply used the machines and all repairs were handled by the production control department. But there was a gradual change of attitude with an increase in general technical knowledge. Everyone found they could easily deal with small problems themselves, and working together, they have gradually eradicated them. At first, there were standard technique study classes. For example, some workers couldn't deal with welding, so they were given lessons in which they could practice and increase their skills. Other workers were not familiar with the basics of bolt tightening, so special classes were begun to help them as well. There are always some people who are not very interested in classes like these at the beginning. But as they progress, they get more involved and see the value of them. enthusiasm spreads throughout the company. At the start, they used to have a lot of equipment downtime, but now that has been greatly reduced to less than 800 minutes per month. This instructor is explaining to new employees various improvements that were made by a relatively young and inexperienced group of workers. Ways to avoid back strain when moving materials over to a metal mold, adding receiving pans to collect metal filings, and a window installed for one-touch checking of a V-belt without removing the cover bolts.
There we are. Operators getting really familiar with their machines and achieving a lot as a result. It's not so difficult, is it? Use your grey matter a bit more and see what you can achieve. More knowledge, more ability, more confidence and more efficiency. Best of luck with it. See you in Volume 3.